Calculating the AMU using the carbon atom lesson. All right, when we go to calculate the AMU, we have to remember a couple of important things. First of all, we have to remember that the mass of a proton is 1.673 times 10 to the negative 27 kilograms. Then we have to remember that the mass of a neutron is 1.675 times 10 to the negative 27 kilograms. And last but not least, we have to remember that the mass of an electron is 9.109 times 10 to the negative 31 kilograms. Also, 1/12 of a carbon atom is equal to 0.08333333333. Now, when we look at the element symbol, which is our carbon here, or also called the nuclear symbol, the C, we note that the atomic number right here is 6. The atomic number represents the number of protons. That's where the 6 comes from here. And that the AMU represents the number of protons and neutrons. Also, it's important to remember that all atoms are electrically neutral unless otherwise indicated. So if you have 6 protons, to cancel out that, you would have to have 6 electrons. How do we know that this is 6 neutrons? Well, it's pretty simple. We use the formula AMU minus the number of protons equals the number of neutrons. So 12 minus 6 is 6. And that's where we come up with the 6 neutrons. All right, so we're going to use a very simple mathematical equation, basically, or process to find the AMU of a carbon atom. So we're going to go protons plus neutrons plus electrons. That doesn't look hard. So we have 6 protons, so we're going to take 6 times 1.673 times 10 to the negative 27 kilograms. We're going to add that to 6 times 1.675 times 10 to the negative 27 kilograms. That's our neutrons. Then we're going to add our electrons, which is going to be 6 times 9.109 better, times 10 to the negative 31 kilograms. So far, pretty easy, huh? So when you multiply and add, multiply and add, multiply and add, you get a number that looks like this. 2.00934 654. Times 10 to the negative 26 kilograms. Okay, so far so good. Now we're going to take that number and multiply it by 1/12, which is 0.083333333. So we're going to go ahead and do that. So we're going to go 2.00934 times 10 to the negative 26 kilograms, okay, times that 1/12, which is 0.0833333. The number we get from that is going to be 1.674 times 10 to the negative 27 kilograms. So far, so easy, right? Not a big deal. But we don't want it in kilograms. We're going to want it in grams, right? Because when we're doing the AMU, we want to figure out grams per mole. So we got to take that number and change it into kilograms. 2 grams. So we're going to change it from kilograms to grams, just like that. Got it? So therefore we go 1.674 times 10 to the negative 27 kilograms times 1,000 grams. Because there's 1,000 grams in every kilogram. Dimensional analysis. Cancel out, And we're going to get 1.674 times 10 to the negative 24 grams. Now we want to take this and turn it into moles. To do that, we go 1.674 times 10 to the negative 24 grams times the mole. Now the mole is 6.022 times 10 to the 23rd. That's the number for the mole. We'll put one mole on the bottom here. Now, we're going to do straight multiplication on that, and we get that 1 AMU is equal to approximately 1.008 grams per mole. Now, when we go calculate the AMU mass, we're going to kind of throw the electrons off. The electrons have some mass, but it's not really significant, right? So we're going to go 6 protons, right? 6 protons plus 6 neutrons gives us 12 for our nucleus. So we go 12 times 1.008, and we get approximately 12.011 grams per mole. So 1 mole of carbon weighs 12.011 grams per mole. And that's how we do this. Pretty cool, huh? And really, really easy. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry!